Hello students, how are you all? I hope you all are fine and doing well. So in last lecture we have studied some electronic instruments, right? We have studied electronic voltmeter, right? So today we are going to start with digital voltmeters, or you can say DVMs. Digital voltmeters, or in short you can call it DVM, right? So in digital voltmeters, what are the advantages of digital voltmeters? First, you can say there is a good accuracy, right? Accuracy is very high. Accuracy is good. Second one, there is no human error. કેમ કે જો આપણે ડાયરેક્ટલી કોઈ એનાલોગ ઇન્સ્ટ્રુમેન્ટ્સમાં વોલ્ટેજ ચેક કરતા હોઈએ, then you have noticed that in your physics lab that one is telling sir it is 7.5 volt, another one is telling sir is 7 volts, another one is telling sir it's 8 volt, right? So it's a human error. But when you are talking about the digital voltmeters, then there is no human error. So you can say no human errors, right? Then the other thing, no parallax error. What is parallax error? Parallax error नहीं होए. Why parallax error मतलब શું? So when you are talking about the analog instruments and that in which pointer is deflected, right? At that time you have to check the voltage, currents, everything from the top of that pointer, right? Generally એ વોલ્ટમીટર અને એમીટરમાં પાછળ એક નાના મિરર જેવું હોય છે, એટલે કે તમારે જ્યારે રીડિંગ લેવાના થાય ત્યારે કમ્પલસરી વોલ્ટમીટરને એક્ઝેક્ટલી ઉપરથી જોવું પડે, એટલે કે પેરેલલ થી. જો તમે સાઈડથી જોવો તો તમારે રીડિંગ ખોટા આવશે, right? So there is no parallax error, right? So you can say these are the advantages of digital voltmeters, right? Or you can say one more thing, it has good speed. Speed પણ બહુ સારી હોય છે, right? So these are the advantages of digital voltmeter. Now I am drawing the diagram of digital voltmeters over here. Please check it out, right? So here it is switch S, right? This one is resistance R, it is amplifier, it is feedback, or you can say capacitor, its positive is grounded. This one is also an amplifier, but here it is positive negative. It is worked as a comparator. Here it is control logic. Control logic. This one is counter. This one is counter. And finally there is one display, or you can say digital readouts. I told you what is the basic difference between digital readouts and digital instruments, right, in last lecture. Here it is a clock pulse. Okay. Now let's understand what happens in this type of digital voltmeters, right? First, here it is Vx and Vr. Vx and V reference, or we can say Vr. So this switch is choosing whether we want to apply Vx, that is applied voltage, or you want to apply reference voltage. આ સ્વિચ નક્કી કરશે કે તમારે રેફરન્સ વોલ્ટેજ આપવો છે કે એપ્લાઇડ વોલ્ટેજ આપવો છે. સપોઝ first we have applied the applied voltage over here and current will flow through this. This one is a amplifier. It will amplify the signal. Now when comparator, after the applied voltage, this switch moves to the reference voltage. અહીંયાથી ને અહીંયા મૂવ થઈ જશે. હવે આ કમ્પેરેટર એ વોલ્ટેજ ને કમ્પેર કરશે બેઝડ ઓન ધી કંટ્રોલ લોજિક. ઓકે, હવે કોઈને મનમાં ક્વેશ્ચન થાય તો આ ક્લોક પલ્સ નું કામ શું છે? સો વી આર એપ્લાયિંગ Vx, or you can say unknown voltage. You can say unknown voltage for some time, and this sometime is measured by clock pulse, right? અને આ જે ટાઈમ છે એ ક્લોક પલ્સ થી ડિસાઈડ થશે. સો અનનોન વોલ્ટેજ અહીંયા આવ્યું, એમ્પ્લિફાઈ કર્યું. હવે કમ્પેરેટર કરવા માટે we need some reference voltage ની સાથે કમ્પેર કર્યું. Then based on this control logic and clock pulse, and this counter will count the timing. It will give you the output in the display, right? Now what happens actually, right, when we are applying some voltages? Suppose we are applying some voltages, unknown voltage. At that time, what happens? When we apply the unknown voltage, the voltage across this capacitor will rise. This voltage across this capacitor will rise, એટલે કે કેપેસિટર ની across ના વોલ્ટેજ માં વધારો થશે. અને when we move this switch to the reference, જ્યારે આ સ્વિચ ને અહીંયાની જગ્યાએ આપણે આવી રીતે કનેક્ટ કરશું, at that time what happen? This voltage start decreasing, એટલે કે કેપેસિટર હવે ડિસ્ચાર્જ થવાનું ચાલુ કરશે. સમજમાં આવી ગયું? તો આ જે ડિસ્ચાર્જ કરવાનો જે રેટ છે એ કોના ઉપર છે અને ચાર્જિંગ થવાનો રેટ કોના ઉપર છે? તો discharge ક્યારે થાય છે? જ્યારે we are applying V reference. So you can say this slope is proportional to V reference, and this charging is based on what? This charging is based on the applied voltage. So you can say the slope of this graph is based on applied unknown voltage. Got it? So you can say this both timing is not same. Why? Because for charging, suppose it takes capital T time, then discharging is always fast, right? So you can say discharging is always faster than the charging process. So I am not writing capital T over here, but I am writing a small t over here. So હું અહીંયા small t રાખું છું અને અહીંયા capital T લખું છું. સમજમાં આવી ગયું? કોઈને કઈ ડાઉટ? Okay. So here you can say similar triangles બને છે. Similar triangles બનવાને કારણે you can say this Vx upon T, or you can just see slope of this and slope of this Vx upon t equals to Vx upon capital T equals to V reference upon small t. So unknown voltage કેટલા હશે, કઈ રીતના કેલ્ક્યુલેટ થશે? તો Vx equals to V reference upon small t into capital T. This is how this unknown voltage is being measured, and these digital readouts will tell you what is the exact voltage. Okay, got it? जल्दी થી નાનો સ્ક્રીનશોટ લઈ લો, જલ્દી કરવાનો સ્ક્રીનશોટ લઈ લો. Okay, I hope you have taken the screenshot. Okay, I am erasing it. Okay, next topic is cathode ray oscilloscope. Cathode ray oscilloscope, or you can call it CRO, right? Got it? Okay. For what type of measurement this CRO is used? For first one is usage. I am writing the usage. If you want to measure the frequency, then this type of CRO is used, right? If you want to measure the unknown electrical quantities, right, it just displays electrical quantities, displays electrical quantities like voltage, current, frequency, etc. Right? If you want to measure the strain, then also you can measure the strain. So strain can be measured, but what we need? But we need some transducers that can convert this strain into electrical signals, right? So strain can be measured, but we need transducers which can convert strain into electrical quantity. Right? So for this type of purposes, you can say this CRO can be used, right? This CRO is giving you two-dimensional display of the signal wave shape What are these two dimensions? Two dimensions kaya kaya છે? First one is horizontal dimension, second one is vertical dimension, right? So suppose this is the screen of CR, right? Here it is look like this. આવી રીતના કંઈક સ્ક્રીન હોય. ચલો, I am doing some better things. આવી રીતના સ્ક્રીન તમને દેખાતી હશે. નાઉ વેવફોર્મ તમારું આવી રીતના આવે છે. See, there are two dimensions. It has some length, right? It has also height. So it is two dimension display. So you can say two dimension displays shows the wave shape of the signal, right? Now I am drawing the block diagram of this CRO. Please watch it carefully, right? First one is vertical amplifier. Here it is input signal. Now this one here it is trigger circuit. Here it is CRT. Here it is sweep generator. Here horizontal amplifier, and this one is given to the CRT, right? Here it is HT supply, and here it is LT supply. This is also given to CRT. This is given for to all circuits. Got it? Okay. This is the basic block diagram of this CRT. Okay. First, what is CRT? I am writing the full form of CRT over here. CRT is cathode ray tube. What is HT? HT मतलब high tension. HT equals to high tension. What is LT? LT is low tension. So these are the full forms of this block diagram. So first let us understand this basic block diagram of CRO. And I am giving you the working, I am telling you the working of all the components connected in this CRO, right? So first one is input signal. So here in input we are going to give some signal that is given to the vertical amplifier. What is vertical amplifier? To increase its height or decrease its height can be done by this vertical amplifier. So if you want to increase or decrease the height, then it can be done by using this vertical amplifier. Then this is given to CRT, or this one is CRT, right? Cathode ray tube. So this one is given to CRT, right? So at the CRT, by using knobs, you can say you can just increase or decrease its height. જે knob આપેલું છે એને ફેરવીને તમે આની હાઈટ ને ડિક્રીઝ અને ઇન્ક્રીઝ કરી શકો છો. એ ડાયરેક્ટલી CRT માં પણ જોવા મળશે. And some portion of it is given to the trigger circuit. એમાંથી થોડોક પાર્ટ આ ટ્રિગર સર્કિટ ને આપવામાં આવે છે. This trigger circuit, what it does, then this trigger circuit just trigger this generator, and this generator generates sawtooth waveforms. Now what are the sawtooth waveforms? The waveforms which has like this, right? These are the sawtooth waveforms. or you can say like this. Generally, these are called sawtooth and these are called triangle waveform. So just remove this one, okay? Okay, these are the sawtooth waveforms. If you want to generate a sawtooth, then you have to use this sweep generator, and this sweep generator is operated by this trigger circuit. So waveform generate કરવા માટે આ trigger circuit હોય છે. Now horizontal amplifier will be compared. What it does, whatever sawtooth waveform are generated, that is compared with this horizontal amplifier, and if you want to just increase or decrease its length, then it can be done by horizontal. તમારે એમની width જે છે એ વધારવી કે ઘટાડવી હોય, then it can be done by this horizontal amplifier. Then it is given to this CRT. આ બધા component ને ચલાવવા માટે you need some supply. તો આ સપ્લાય LT સપ્લાય છે જે લો વોલ્ટેજ છે, મેબી 12 વોલ્ટ હોઈ શકે, કે જેટલા વોલ્ટેજની જે પણ સર્કિટને જરૂર છે એટલા વોલ્ટેજ આ LT સપ્લાય પ્રોડ્યુસ કરીને કમ્પોનન્ટ્સને આપશે. બટ એઝ યુ નો CRT તમે તમારા જૂના ટીવીમાં ડબ્બા ટાઈપના ટીવીમાં જોઈ હશે, એ CRT ને ચાલુ થવા માટે it needs approximately 1000 volts. If you don't give 1000 volts, then this CRT will never start. So to start this CRT, we need HT, high tension supply, and to run all the components of CRO, we need LT supply. Got it? બધાયનું components નું જે પણ વસ્તુ છે એ ખબર પડી ગઈ છે. Okay, I hope તમને બધું ખબર પડી ગઈ હશે. જલ્દીથી નાનો સ્ક્રીનશોટ લઈ લો, જલ્દી કરો, સ્ક્રીનશોટ લઈ લો. Okay, I hope you have taken the screenshot. So today we are going to over this lecture over here. Whatever I have told, just write it in your book. Don't write like this because it's just an explanation. You have to write each and every point, right? So you can use your reference books. Okay, so today we are going to over this over here. Thank you so much and have a nice day.